Again, this is similar to when you were removing the greatest common factor with a single variable. Distribution is when a term on the outside of a set of parentheses is distributed to each term inside of the parentheses. So if you had 2x squared y to the fifth times 3 minus 4x y to the third, this term on the outside would be multiplied times each term on the inside, giving us 2 times 3, which is 6. X squared y to the fifth remain the same since this term doesn't have any x's or y's. 2x squared y to the fifth times negative 4xy to the third would give us 2 times negative 4, which is negative 8. And when we are multiplying the variables, we add the exponents. X squared times x would give us x cubed. 2 plus 1 equals 3. And y to the fifth times y to the third gives us y to the 5 plus 3, which is y to the eighth. So if this term can be distributed to each term on the inside here to give us this final product, reverse distribution is how we would remove the greatest common factor from this polynomial. We first want to remove the largest number that is a common factor of the coefficients first. Our coefficients are 6 and negative 8. So 2 is the greatest common factor of those coefficients. So we can take that out. We then want to go to each individual variable. So we'll start with the x's. We have x squared and we have x to the third. X squared is common in both. You have 2 x's in both. You do not have 3 x's in both. So x squared is the greatest common factor, so we take that out. And then you go to the next variable, which in this case is y. We have y to the fifth and y to the eighth. So the greatest common factor of the y's is y to the fifth, since you have 5 y's in each, but you do not have 8 y's in each. You only have 5 here. So when you remove the greatest common factor of y to the fifth, you take that out. And the two factors for 6x squared y to the fifth minus 8x cubed y to the eighth would be 2x squared y to the fifth. And the second factor would be 3 minus 4x y to the third. So removing the greatest common factor from an expression that has multiple variables is the same exact process of removing the greatest common factor of an expression that has a single variable throughout the terms. So let's take a look at this example. Let's say you were asked to factor by removing the greatest common factor and then check the answer for negative 32 x to the fourth, y to the 10th, z to the 6th, plus 8x to the 7th, y to the 5th, minus 24 x to the 3rd, y to the 4th, z squared. So the first step, same as before, remove the greatest common factor from the coefficients. So the coefficients, we have negative 32, positive 8, and negative 24. Each of these three numbers can be divided by 8. We then take a look at our first variable, x. So the second step, remove each variable and the largest exponent common to each term. So when we look at our x's, we have x to the fourth, x to the seventh, and x to the third. X to the third is the largest x that we can take out of each one, since it is common in all three. X to the fourth, for example, cannot be removed, since this term does not have 4 x's to take out, but it does have 3. We then look at the next variable, y. We have y to the 10th, y to the 5th, and y to the 4th. 4 y's are common in all three, so we can remove y to the 4th. And now we look at our z's. Z to the 6th is in the first term. There is no z in the second term, and we do have a z in the third term. But since z is not common in all three terms, then there is no z in the greatest common factor, since it is not common here. So our greatest common factor is 8x cubed y to the 4th. And now we can figure out the second factor by dividing each term in the original polynomial by the greatest common factor, 8x cubed y to the fourth. When we do so, we get negative 32 divided by 8 would give us negative 4. X to the fourth divided by x cubed is equal to x to the 4 minus 3, which is x to the 1, or just x. We then look at our y's. Y to the 10th divided by y to the fourth is equal to y to the 10 minus 4, which would be y to the 6th. We have z to the 6th divided by no z's, so we keep z to the 6th. And now that we've divided the first term by our greatest common factor, we then move on to the second term. 8 divided by 8 is equal to 1, so we do not need to show that. X to the 7th divided by x to the 3rd is equal to x to the 7 minus 3, which would be x to the 4th. And y to the 5th divided by y to the 4th is equal to y to the 5 minus 4, which is y to the 1st, or just y. And when we divide the third term, we get negative 24 divided by 8, which is negative 3. X cubed divided by x cubed is 1, so we can remove the x. Y to the fourth divided by y to the fourth is equal to 1, so we can remove the y's. And we have z squared divided by no z's, which remains z squared. So when we factor the polynomial by removing the greatest common factor, 8x cubed y to the fourth, we wind up with the factors 8x cubed y to the fourth times negative 4x y to the 6th z to the 6th plus x to the fourth y minus 3z squared. And to check the answer, you want to multiply the factors. So we have 8 times negative 4, which is negative 32. X to the third times x would give you x to the 3 plus 1, which is 4. Y to the fourth times y to the 6th gives you y to the 4 plus 6, which is 10. And z to the 6th times nothing is just z to the 6th. Now we multiply the greatest common factor times the second term in here. 8 times positive 1 is positive 8. X to the third times x to the fourth is equal to x to the 3 plus 4, which is 7. Y to the fourth times y is equal to y to the 4 plus 1, which is 5. And for the last term, we get 8 times negative 3, which is negative 24. X cubed times nothing is x cubed. Y to the fourth times no y's is y to the fourth. And z squared times no z's is z squared. So since our final polynomial matches our original polynomial, that confirms that these are the factors of our polynomial. So that is how you would go about factoring a polynomial with multiple variables by removing the greatest common factor. Let's now have you try a few practice questions. So factor by removing the greatest common factor. Question number 1, 15x cubed y squared minus 9xy plus 12x to the fourth yz squared. Question number 2, factor by removing the greatest common factor of negative 8x to the fifth y to the seventh plus 6x cubed y to the fourth minus 2x to the fourth y cubed, and then check the answer. In question number 3, factor by removing the greatest common factor of 20x cubed y cubed minus 5x y cubed plus 15x squared y to the fourth minus 10x to the fifth y to the seventh, and then check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. You were asked to factor 15x cubed y squared minus 9xy plus 12x to the fourth yz squared by removing the greatest common factor. Step 1, remove the greatest common factor from the coefficients, 15, negative 9, and 12. And the greatest common factor of these three numbers would be 3. Step 2, remove each variable and the largest exponent common to each term. So we have x to the third, x, and x to the fourth. X is common in all three, so that is part of our greatest common factor. And now y, we have y with an exponent of 2, y with an exponent of 1, and y with an exponent of 1. So the y to an exponent of 1 is common in all three, so we remove that. And for our third variable, z, we only have z in one term. So since it cannot be removed from all three terms, it is not a part of the greatest common factor. So the greatest common factor for this polynomial is 3xy. And now to figure out the second factor for this polynomial, you want to divide each term in the original polynomial by the greatest common factor, 3xy. When you do so, we get 15 divided by 3, which is 5. X to the third divided by x is equal to x to the 3 minus 1, which is 2. And y to the second divided by y is equal to y to the 2 minus 1, which is 1. And now we can move on to our second term, negative 9xy. When we divide that by the greatest common factor, we get negative 9 divided by 3, which is negative 3. X divided by x is 1, so we can remove the x's. Y divided by y is 1, so we can remove the y's, leaving us with just negative 3. And now the third term, we divide it by the greatest common factor. We get 12 divided by 3, which is 4. X to the fourth divided by x is x to the 4 minus 1, which would be 3. And z squared divided by no z's is still z squared. So the factors of this polynomial are 3xy times 5x squared y minus 3 plus 4x cubed z squared. Now step 4, check the answer by multiplying the factors. When we do so, the final product should be our original polynomial. 3 times 5 is 15. X times x squared is x to the 1 plus 2, which is 3. Y times y is y squared. Then we have 3 times negative 3, which is negative 9, times xy. And then lastly, 3 times positive 4 is positive 12. X to the first times x to the third is equal to x to the 1 plus 3, which is 4. We only have one y, so we keep that. And we have z squared, so we keep that. So since our final polynomial matches our original polynomial, that confirms that the factors are 3xy and 5x squared y minus 3 plus 4x cubed z squared. Let's now have a look at question number 2. We were asked to factor by removing the greatest common factor of negative 8 x to the 5th y to the 7th plus 6x cubed y to the 4th minus 2x to the 4th y cubed. Step 1, remove the greatest common factor from the coefficients, -8, +6, and -2. And the greatest common factor would be 2. We then move on to the variables by removing each variable and the largest exponent common to each term. So starting with our x's, we have x to the 5th, x to the 3rd, and x to the 4th. X to the 3rd is common in all three. This one has 4 x's, this one has 5 x's. So they all have at least 3 x's. So that's part of our greatest common factor. And then y's, we have y to the 7th, y to the 4th, and y to the 3rd. Each term has at least 3 y's. So y to the 3rd is a part of our greatest common factor. So the greatest common factor that we removed is 2x cubed y cubed. And now to figure out the second factor, we want to divide each term in the original polynomial by the greatest common factor, 2x cubed y cubed. And when we do so, we get -8 divided by 2, which is -4. X to the 5th divided by x cubed is x squared. 5 minus 3 gives us 2. And y to the 7th divided by y to the 3rd gives us 7 minus 3, which is y to the 4th. And now we move on to the second term. 6 divided by 2 gives us +3. X cubed divided by x cubed is 1, so we can remove it. Y to the 4th divided by y to the 3rd is equal to y to the 4 minus 3, which is 1. So that gives us just y. And now the third term, -2 divided by 2 is -1. X to the 4th divided by x to the 3rd is x to the 4 minus 3, which is 1. So it's just x. And y to the 3rd divided by y to the 3rd is 1. So we can remove y. So our second factor is -4x squared y to the 4th plus 3y minus x. So we get 2x cubed y cubed times -4x squared y to the 4th plus 3y minus x. And now to check the answer, you want to multiply the factors. And when we do so, our final polynomial should match our original polynomial. So we get 2 times -4, which is -8. X cubed times x squared is x to the 3 plus 2, which is 5. Y to the 3rd times y to the 4th is equal to y to the 3 plus 4, which would be y to the 7th. Now we multiply 2x cubed y cubed times 3y, giving you 2 times 3, which is 6. X cubed times no x's is x cubed. Y cubed times y is equal to y to the 3 plus 1, which is 4. And then we multiply the greatest common factor times -x, giving us 2 times -1, which is -2. X to the 3rd times x is equal to x to the 3 plus 1, which is 4. And y cubed times no y's is y cubed. So our final polynomial matches our original polynomial, which confirms that the factors we were looking for are 2x cubed y cubed and -4x squared y to the 4th plus 3y minus x. And let's have a look at question number 3. You are asked to factor by removing the greatest common factor from 20x cubed y cubed minus 5xy cubed plus 15x squared y to the 4th minus 10x to the 5th y to the 7th. Step 1, remove the greatest common factor from the coefficients. The coefficients are 20, -5, +15, and -10. The largest number that is a common factor to all 4 of those numbers is 5. Step 2, remove each variable and the largest exponent common to each term. We have x to the 3rd, x to the 1st, x to the second, and x to the fifth. Only x to the first is common in all four, so x is a part of our greatest common factor. Then we take a look at the y's. We have y to the third, y to the third, y to the fourth, and y to the seventh. Y to the third is common in all four, so y to the third is a part of our greatest common factor, which winds up being 5xy cubed. And now, since we found the greatest common factor, we want to divide each term in the original polynomial by the greatest common factor. That will help us find the second factor for the polynomial. When we do so, we get 20 divided by 5, which is 4. X to the third divided by x is equal to x to the 3 minus 1, which is 2. Y to the third divided by y to the third equals 1, so that cancels out. We then move on to the second term. Negative 5 divided by 5 is negative 1. X divided by x is 1, so we can remove the x's. Y to the third divided by y to the third is equal to 1, so we can remove the y's, leaving us with just negative 1 here. We then move on to the third term. Positive 15 divided by 5 is positive 3. X squared divided by x is equal to x to the 2 minus 1, which is x. And y to the fourth divided by y to the third is equal to y to the 4 minus 3, which is 1. So we wind up with positive 3xy here. And the last term, negative 10 divided by 5 is negative 2. X to the fifth divided by x is x to the 5 minus 1, which is 4. And y to the seventh divided by y to the third is equal to y to the 7 minus 3, which is y to the fourth. So we wind up factoring the polynomial into 5xy cubed times 4x squared minus 1 plus 3xy minus 2x to the fourth y to the fourth. And now to check the answer, we want to multiply our factors to confirm that we get a polynomial that matches our original polynomial, giving us 5 times 4, which is 20. X times x squared is x cubed, and we keep y to the third. We then have 5 times negative 1, which is negative 5, and we keep xy cubed. We then have 5 times 3, which is 15. X times x is x squared. And y to the third times y is y to the fourth. And then we have 5 times negative 2 is negative 10. X times x to the fourth is x to the fifth. And y to the third times y to the fourth is y to the seventh. And since our final polynomial matches our original polynomial, that lets us know that we found the factors of that polynomial, which are 5xy cubed and 4x squared minus 1 plus 3xy minus 2x to the fourth y to the fourth.